Have you ever felt like time is just flying by? Well, what if I told you that's literally true, and it's happening differently for different parts of your body right now? It sounds like something straight out of a sci-fi movie, but it's a real, measurable phenomenon. Believe it or not, time actually moves slower for your head than it does for your feet. This isn't just some quirky thought experiment. It's a direct consequence of one of the most brilliant ideas in human history, Albert Einstein's theory of general relativity. To wrap our heads around this, we need to forget everything we thought we knew about time. Most of us imagine time as a constant, universal clock, ticking away at the same rate for everyone, everywhere. But Einstein showed us that's not the case. He revealed that time is not separate from space. Instead, they are woven together into a single, four-dimensional fabric called space-time. Now, imagine this space-time fabric is like a giant, stretchy trampoline. If you place a bowling ball in the middle of it, the fabric will bend and curve around the ball. This is exactly what massive objects, like planets and stars, do to space-time. They warp it. And here's the crucial part. Gravity is not a mysterious force pulling things together. Gravity is simply the effect of objects moving along these curves in space-time. So, the Earth isn't pulling you down. It's bending space-time around you, and you're just following that curve. This warping of space-time has a profound effect on the flow of time. According to Einstein, the stronger the gravitational pull, the more space-time is curved, and the slower time passes. This is a concept known as gravitational time dilation. The closer you are to a massive object, the more you feel its gravity, and the slower time ticks for you. Let's bring this back down to Earth, literally. The Earth has a massive gravitational field. Since your feet are closer to the center of the Earth than your head is, they experience a slightly stronger gravitational pull. It's a minuscule difference, but it's there. Because of this tiny bit of extra gravity. Time for your feet is running just a fraction of a second slower than it is for your head. You might be thinking, okay, that's a cool idea, but is it even noticeable? In our everyday lives, absolutely not. The difference is so incredibly small it's almost unimaginable. We're talking about a difference of nanoseconds, or billionths of a second, over your entire lifetime. To put that in perspective, a nanosecond is to a second what a second is to about 32 years. So, no, you won't age faster by standing on your head. But here's where it gets amazing. We can actually measure this effect with modern technology. Scientists have used incredibly precise atomic clocks, which are the most accurate timekeeping devices ever created. They are so sensitive they can detect these tiny variations in the flow of time. In one famous experiment, researchers placed one atomic clock on the floor and another on a shelf just 33 centimeters, or about 1 foot, higher. After running the experiment, they found that the clock on the shelf had indeed ticked ever so slightly faster than the clock on the floor. They had directly measured time dilation over the distance of just 1 foot. This confirmed Einstein's prediction with stunning accuracy. The implications of this are mind-boggling. It means every single step you take up a flight of stairs. You are literally traveling a tiny, tiny bit into the future relative to someone on the ground floor. When you fly in an airplane, you're further away from Earth's gravitational center. So time for you moves slightly faster than for people on the ground. Pilots and frequent flyers are technically a few microseconds older than they would be if they had stayed on the ground. This isn't just a quirky bit of trivia, either. Gravitational time dilation is essential for technologies we use every single day. The Most prominent example is the Global Positioning System, or GPS. The GPS network relies on a constellation of satellites orbiting the Earth. These satellites are very far from the Earth's surface, where gravity is weaker. Therefore, the atomic clocks on board these satellites tick faster than clocks on the ground by about 38 microseconds every day. If engineers didn't account for this time difference, the entire GPS system would fail spectacularly. A 38 microsecond error might not sound like much, but in the world of GPS, it's a catastrophe. Light travels about 30,000 kilometers per second. So even a tiny time error would translate into a huge location error. If we ignored relativity, the GPS system would accumulate errors that would throw off your location by about 10 kilometers or 6 miles every single day. Your phone's navigation app would be utterly useless, telling you to turn right into a field when you're still miles from your exit. So, every time you use Google Maps to find the nearest coffee shop, you are relying on Einstein's theory of general relativity. The effect becomes even more dramatic when we look at extreme cosmic objects. Take black holes, for example. A black hole is an object with such immense gravity that it warps spacetime to an extreme degree. As you get closer to a black hole, time slows down dramatically. If you could hover near the edge of a black hole, known as the event horizon, time for you would pass incredibly slowly compared to someone far away. Hours for you might be decades or even centuries for them. This is the premise of the movie Interstellar, where astronauts visit a planet near a supermassive black hole and experience this extreme time dilation firsthand. What felt like a few hours for them was 23 years for the crew member who stayed behind in orbit. While the movie takes some creative liberties, the fundamental science is real. So, the next time you're standing up, take a moment to appreciate the incredible physics at play. Your head is traveling into the future just a little bit faster than your feet. Time is not the rigid, unchangeable river we often think it is. It's a dynamic, flexible dimension that is stretched and squeezed by the gravity of everything in the universe. We are all time travelers in our own small way, constantly moving through spacetime at slightly different rates. The universe is a far stranger and more wonderful place than we can often imagine, where even the simple act of standing up connects you to the deepest secrets of space and time. Thank you so much for joining me on this journey through spacetime. If you found this as fascinating as I do, make sure to hit that like button and subscribe for more deep dives into the weird and wonderful world of science. Let me know in the comments what other mind-bending topics you'd like to explore. See you in the next one.